Evo, pozdrav svima, dobrodošli na još jedno GoTalk predavanje koje radimo u sklopu projekta Škola budućnosti. Želimo se zahvaliti svim našim sponzorima i partnerima koji omogućavaju da ovaj projekt dođe u čim veći broj škola. Tu su STEM, Infobip A1, Infineon, Croatia osiguranje, Bosch, Grad Pula, Spanavel, Belmet, Aluplex i Aspira. I velika nam je čast da danas možemo ugostiti zbilja velikog čovjeka iz Infineona, zove se Christopher Kögler. I Christoph ima više od 25 godina iskustva rada u Europi i Silicijskoj dolini, radio na područjima razvoja softvera, Internet of Things, cloud computing i umjetne inteligencije. Danas u Infineonu vodi multinacionalni tim eksperata koji rade digitalnu transformaciju u industrijskoj primjeni poluvodiča koristeći umjetnu inteligenciju. A što je točno Infineon, čime se oni bave i kako primjenjuju umjetnu inteligenciju i robotiku u svom radu, reći će vam Christoph i predavanje će biti na engleskom, tako da ću se ja sada prebaciti na engleski. Hello, Christoph.
Hey, hello. Dobrodošli.
We are very happy to have you here. Please, you can share your presentation, and
Yes.
while you are doing that, I will tell to all attendees, tell us in chat where are you coming from. Feel free to ask any question during the presentation. I'll be following the chat, and then when Christoph finishes with the lecture, we'll have a Q&A. So, Christoph, here is your presentation, and feel free to start.
Great. Thanks a lot. I'm very happy to join you today about my work, about digitalization, and about spying on robots. That's actually an interesting topic. I'd like to talk to you. So maybe a few words about me and the company I'm working for. So I'm Christoph. I'm working here in Dresden in Germany. For Infineon Technologies. And Infineon Technologies, you probably know, we are one of the global leaders in automotive power management, energy efficient technologies, and the IoT, the Internet of Things. So what are we doing? We're producing chips and digital solutions. So the things you have, for example, here in your smartphone or in your smartwatch, the chips, they come mainly from Infineon. So even in the automotive market, I think we're number one. Also in power electronics, so everything that controls the flow of electric currents, of electric power, we are the number one. And in microcontrollers, so the things that compute, we are number 4 actually on the market. What are the fields Infineon is active in? So as I said, automotive is an important part, but also green industrial power, which is very important for today because the world is going to decarbonize. It's going to use more renewable power, and that's a big market for Infineon. So everything that produces energy, might be solar energy or wind energy, uses our chips. Also power and sensor systems. So we will talk a little bit about sensors today. So how to use a sensor to do some interesting spying on robots. That will be this part. And also in security systems. So for example, if you have an electronic passport, you have a good chance to have a chip from Infineon in this electronic passport. We are a global company, so you see here the locations where Infineon is active. Front end and back end just mean different things in producing semiconductors. It's not that important, but it's the regions where we are active. So I'm currently in Dresden, and you see we are also quite away in Europe. So in Warstein in Germany, in Regensburg, also in Zagreb in Hungary, in Villach in Austria. And then also in Asia, we have a lot of fabs there, and also in the United States and in the Americas. So that's the locations where we are. So I'm talking to you today from the Dresden location. So I'm working here in Dresden in the development center. So that's a special part of Infineon where we do research and development. So my job is to come up with new products for Infineon, especially for the Green Industrial Power Division, which does all this power semiconductor business. for Infineon, especially for our industrial customers. So about 13% of the annual revenue of Infineon goes into research and development. So we invest a lot into coming up with cool new products. And we also do this in 59 sites in 35 countries all over the world. And finally, a lot of interesting people are working here at Infineon, and we will also see a little bit how sensors and people connect here at Infineon, the project I want to describe to you. So you have people, for example, working in field sales. You have maintenance technicians that are the ones I want to support with my sensor solution today. So we will see a little bit more about Thomas and what he's doing and how we can support him. Also, there are field application engineering people. So, for example, Marcel in Munich or Dr. Pamela Lin working in Singapore as a data scientist. Also, people, for example, I have here in my teams. So it's really a broad community. It's an international community. Really is a lot of fun to work for Infineon and work on new groundbreaking technologies. And one of the things we are doing is actually spying on robots. So let me tell a little bit about that. How we can fix valves, how we can fix robots by doing spying on them. So spying really means listening to them and how we can predict failures just by listening to complex machinery. So that's what I want to tell you a little bit today. One of the important applications of our sensors is predictive maintenance. So really knowing before something breaks, that's very important. So you're not see if something breaks, you can see it even before, and you can prevent something from breaking by seeing it before. That's the main topic. Okay, so as I said, semiconductor manufacturing, where Infineon is into, is really a bleeding edge high-tech industry. So it's completely automated. So you don't see a lot of people in our fabs. It's mainly technicians who are caring for the machinery. Most of this is going on automatically. So on the left side on the picture, you see one of the wafers. That's where the chips are being produced. It's a clean room environment. So on the right picture, you see you have a special clothing there in the clean room. You don't want to have any dust in there that can contaminate the wafers. So it's a very clean environment. It's very automated, a lot of robots going on there. So that's the industry and the way how we produce that. And also because it's such a high-tech industry, so it's a lot of very complex and very expensive machinery working there. It's also in an area and an industry, the semiconductor manufacturing, that is, I would say, one of the early adopters of these predictive maintenance solutions. So can you really use an artificial intelligence, something that computes something? Can you use a sensor to predict if a machine will fail or not? And that's something we already use in semiconductor manufacturing, and I will show you a small example from that. So maybe a few words also about the region where we are here. So I'm situated in Dresden, and we call this region Silicon Saxony. Saxony is the federal state of Germany, where Dresden is the capital of. And it's really Europe's biggest IoT cluster. So a lot of companies concerned with the Internet of Things are situated here in Dresden. So Infineon is not the only one who's here who's producing semiconductors. There are a lot of other fabs. So, for example, Global Foundries, and they were also partners in this project. There's Bosch here. There's X-Fab, Renesas. So a lot of institutes and a lot of companies who produce semiconductors are situated here in Dresden. So it's really the biggest cluster. You also have a lot of software companies. So, for example, SAP, Deutsche Telekom, T-Systems, they are situated here in Dresden. And a lot of research organizations. Also, you see all these Fraunhofer institutes who are doing basic research on how to do good semiconductor products. There's also a lot of universities here. So it's really a good environment, an international environment where you can do really a lot of innovation. And it's also situated on the border to Poland and the Czech Republic. So we also have a lot of contacts there and a lot of network to Poland and Czech Republic and to other countries. So it really is fun to work here. So what was the idea? So you saw before on the slide Thomas, the technician. So his job is to make sure that the machinery is always working. He's caring for the machinery, and it's really a hard work. And we had the idea, can a tiny sensor support Thomas, and can a tiny sensor maybe do the work of a highly experienced maintenance specialist like Thomas? So you see on the right, you see this tiny sensor. It's actually this the small golden things on the left and on the right side. That's the actual sensor. It's smaller than the tip of your finger, actually, and that's a microphone that can detect sound. You will find it, for example, in your phone, such type of microphones. But we had the idea, can we support Thomas as a maintenance technicians by just listening to machinery? Why do we have this idea? So we talked to Thomas and as a maintenance specialist and asked them, so how do you know if a machine will break? How do you know it before? And they told us, yeah, well, we listen to the machinery. It may emit a different sound. It may sound a little bit different. And that's a clue for us that we see, okay, this might fail. There might be a problem. It's maybe the same thing like you do, for example, with your car. Your parents do with a car. So something doesn't sound really like it should be, and you see, okay, there may be a breakage. I should have a look to the motor. That's more or less the same like we do it. Of course, it's a lot more complex. It's a lot more complex machinery, but a basic principle, it's still you can listen to things and you can hear if something will break or not. So that was the idea that we had here. Can we use a sensor and some automation to do that? We had also a lot of partners going on. So Infineon provided the sensor for this project, but there were also other companies that are here situated in the region of Dresden helping us with this project, mainly Global Foundries. I've had a company also producing semiconductors. They were partners in the project. Also T-Systems, which is a software company. And actually, when we started this program, I still was a project manager and a manager at T-Systems. So I joined Infineon just last year. So after I did a project at T-Systems, we had also on board CodeRedder, which is a small startup from Dresden. They are very good in doing artificial intelligence on small devices. So they helped us a lot to write the software for the system. And the whole thing was pulled together by the Smart Systems Hub. And Smart Systems Hub is a conglomerate, a corporation of different companies here in Dresden who are all working on this Internet of Things project. So where you need hardware, where you need software, you need a connectivity between them, you need something that calculates things. So a lot of companies here in the Silicon Saxony region are cooperating in the Smart Systems Hub and doing these kinds of projects together. So the first application where we try to do this, what I described before, can we really listen to machinery and can we detect a failure there just by listening to the machinery? The first applications were pure water pumps. I can show you a little bit how this looks like. So let's have a look into the rooms where those water pumps are. This is actually a level below the clean room, what you see here in the video. So all this complex machinery is one level above. And in this level down here is all the machinery that provides all the chemicals, the water, the electricity for the machines that produce the semiconductors. So you see, it's really a maze of a lot of piping going on there, and we selected these orange valves that you see here in the pictures to have to be our first application for this project. So these orange valves, they control the flow of water. So to produce semiconductors, you need a lot of chemicals, but you also need this very clean and pure water just to wash the wafers, to make them clean before you can do the next step in producing them. And it's very important that these valves don't fail, that they work every time. So we put here, you see this here just in this picture. So we put a little sensor just with duct tape to the valve and to monitor this. So you have this box here. It's all looks a little bit like in the lab still. It was the first proof of concept that this works. Yeah, and then we put a chip in here and we really listened to the machinery and try to detect if it's okay or if it's not okay. So that's how this looks like. So what you see here is just a representation of the sound. So you see different frequencies, and you see it at the time here, how this changes. So this one here on the left side, these are different frequencies. So lower frequencies on the bottom, higher frequencies on the top, and then how this changes over time. And you can see really the top picture is from a normal valve, so from a normal pump. That's fine. And when you look below, you already see just by your eyes, and you can also hear this that there's a difference. So if the valve is malfunctioning, it just sounds different, and you can detect this. So we just trained an artificial intelligence neural network chip on that to detect this different sound, and then we could say, okay, the valve is okay or it's not okay. So Thomas, our technicians, didn't have to go to every pump and have to check this. He can just look now on the screen, and he can see, okay, the valve is okay, or there's probably a failure there if it looks more like that. And he can go to the machinery and then can attend to that. So that was the first applications where we did this. It was, I think, relatively easy because it's a stationary pump. You just put a microphone on that. It was not that difficult, but it was the first project we did in this area. So we broke a lot of new ground in doing that. So here a little bit about how this looks like from a technical side. So you have the valves here, and you have the microphone on the valve. So then you have, we call this an edge AI, so an edge artificial intelligence. So that's a special chip that's in the gateway. So this is the black box you saw in the video before. So this is something that computes already some data that collects that, and then we have, so we call this the cloud environment. That's really in the computing centers where we have the machine learning model, where we process all the data, and we build a model how this should sound a valve, and then we deploy this to this edge gateway, so the edge gateway can then compare the sound that it's hearing from the valve to what it should hear, and then it can say if it's okay or not. So that's the software part that we built there. Okay. So after having done that, we got a little cookie and said, "Hey, well, let's say if we can apply this to other things, maybe we can apply the same principle to more complex applications." And so we had a look on our overhead transport system. The overhead transport system is very important. It's you find something like that in all modern semiconductor fabs, and again, we can have a look into that. So you see on the ceiling, there are these cars going on. So they go automatically, and what they do is they transport the wafers. They are inside boxes, and they transport them from one machine to the next machine to do the next production step. It's all automated. So you see them going around here, all the vehicles coming up here. And then they go over the machine, and then they position themselves over the machine, and they lower the boxes with the wafers and take the wafers out of them, and then transport them to the next machinery. So it's very important that they run every time. So you won't have one that fails there on the rail. So here you can see it. It goes down, takes the boxes here from the wafers, so it connects to them, then it hosts them to the top, and transports them to the next machinery. So that's actually a picture here from the Global Foundries clean room, where we had the first installation of the system. So just neighboring here in Dresden, and there are some challenges when we try to do this. So what we tried to do was an overhead transport system, so OHT health predictor. So we want to mount the microphone here on the rail on the top. So not on every vehicle, we wanted to mount it on the rail. And then when the vehicle is going by, we wanted to just listen to the vehicle and then see if there's some breakage. So typical things that can break in these kinds of vehicles are, for example, you have here, so there are wheels here, there are ball bearings in the wheels, and they can fail, so they can be damaged. Also, they have brakes, the vehicles, and The brake, for example, might not opening, so it's scraping along the rail there, or other things that can break. But again, it's a lot of things you can hear, and that's what we try to do, just mounting a sensor here in the rail, and then when the vehicle goes by, to identify if it's okay or not. So some challenges we had in that, of course, there are a lot of vehicles which you have to identify. So you have to know which vehicle is just going by in the moment there. So, for example, we have a few hundreds of these vehicles going on here every day. So they're constantly moving, and you have to know, okay, which number is the one which you just heard here by the microphone. We also had some additional data sources there. So it was not only the microphone, not only the sound. We wanted to use also other data sources. So, for example, there's a database computer that stores messages from these vehicles. And we wanted to have a look into that database to see if there are some failures the vehicle have already put out that we can use also to predict if the vehicle is okay or not. And also scalability. Scalability means can you really do this on a big scale? So in the project before, we had just a few pumps. And I think it's relatively easy to do this for a few pumps, but do this for, let's say, here in one fab for a couple of hundred of these vehicles. And then, of course, you want to do this on all the fabs you have globally. And I showed you in the beginning how many fabs Infineon have. There are also other semiconductor manufacturers who have a lot of these fabs. So really, when you do this in a lot of fabs, you have to build a system that can do this really globally and worldwide. And that's something we try to do here in this second project. So again, here you can see some representations of the sound. So it's again, on the bottom is the time, so how the sounds when the vehicle comes and then goes by. So it's just a few seconds of sound that you collect here. Then you have an amplitude here, so that's mainly how loud or how low the signal is that we have here. And you also see when you look here at the representation of an abnormal signal, so something that's broken, you see it's a lot noisier. Yeah, so the bars are higher here, so it emits a lot of more sound. So, for example, because the ball bearing is breaking, it's clanking, it's emitting some stuff, or the brake is scraping along the rail or something like that. So you can really hear this. And again, we trained an artificial intelligence or a neural network to detect these kinds of sounds we have here. That was again relatively easy, straightforward to do this, and then we could detect if the vehicle is okay or not. We even tried to detect different types of failures. So, for example, we tried to detect if it's a brake that's scraping, or if it's a ball bearing that's broken, or if it's there are some control rods in the front of the vehicle. They can be bent and they emit a different kind of sound. So we even try to distinguish between these different failures and could do that. So that was the, I would say, the relatively easy part also for our data scientists to do that. And we also had here this different database in there, so where we had a look into the database of the vehicles. We did this at first just to see what number of the vehicle is just going by at that position. So you have to know what is the vehicle you're listening to, and that we did by looking into the database. But we also looked here at some error messages the vehicle put into the database to have this as an additional data source to see then on a dashboard. So a dashboard is just a representation on a computer screen where you see all the vehicles, and then you can say, okay, vehicle number 345 or something like that. It's fine. It's probably okay. It sounds okay, but maybe 347. It sounds like there's a ball bearing broken or something like that. And you can also see here how this looked like. So we had this installed on the rail. So it still looks a little bit like in the lab. So a lot of cables going on here. This was just to try this. And then later we built a better box. I show you that. And we also had here some sensors. That's an ultrasonic sensor. So it's ultrasound. It just detects when a vehicle is approaching this microphone so that we can just record the few seconds of sounds we need when the vehicle actually is going by. So that was the things that we had here. So what does it mean to do something like that for business? So we talked here to our colleagues from Global Foundries, and Lars, he is one of the technicians at Global Foundries here in Dresden. And he told us, so the main thing that you have by such a system is that you can reduce the downtime. So downtime means if a vehicle breaks, you can imagine on those rails, if a vehicle stops because it's broken, it's immediately a traffic jam there. So vehicles can't go by, they can't just overtake on this rail there. So you have immediately an impact on your production. So the wafer boxes can't go from one machine to the other. So you just lose output of your factoring. That's something you see immediately in money and in revenue. So that's something we want to prevent. And Lars from Global Foundries, he suggested, well, we can save the 25 to 35% of these things when the vehicle are really breaking down and jamming our rail there. So that's the first thing. But also, if you look how you do this maintenance of the vehicles, of course, because you don't want them to break, what you actually do is you do a lot of effort in making sure that these vehicles don't break. So you inspect them regularly. Again, probably the same like your parents do with the car. So you once in the 2 years or so, you go to you take your car to an inspection. You see if everything is okay. It gets a sticker on the bag and can go back on the street. And that's exactly what our technicians here and the technicians from Global Foundries are doing. So that's the work from Thomas, the technician here. So regularly inspecting the vehicles, seeing if everything is fine, and then put them back on the rail. So they do this regularly, and of course, this takes a lot of effort. And of course, in most cases, the vehicle is just fine. It's okay. You see, everything is fine, and you put them back on the rail. And then now by having this microphone there and having this predictive maintenance solution, you can have something like that. So you see a list of all the vehicles, and you can just see a value, how healthy or not the vehicle is. So you don't have to inspect every vehicle, at least not that often. You just see the vehicles. So, for example, you can see here it's 59 that probably have some critical error there, and you can take care of them first. So that's really the difference to before. Instead of inspecting every vehicle in a fixed interval, you can just look at these vehicles who are sound a little bit different, and where you can see, okay, there might be a problem, I can inspect them first. And that allows our technicians to do a lot of more work, to do a lot of more vehicles, to care for them with the same number of people we have at the moment. So it's really a big impact on business. And this also can be done in other industries, so not only in the semiconductor industries. So you can do the same thing, for example, for cars. Maybe in a few years, your car has a microphone in it, and it can detect if something sounds not really right in the motor, and it can suggest you should go to a maintenance station. You should have a look on the motor because there might be some breakage in there. Some things we learned along the way. This project. So one thing we learned, actually the position where you put a microphone on the rail. So you can choose every spot, but it's really important to choose the right spot. So in the first project we did, we had this microphone on a bridge between two clean rooms. So that's what you see here on the photo. So you just come out of one clean room, and the vehicles go here, this long tunnel, and then they enter the next clean room. And we choose especially that location because the vehicles are here moving at full speed, so they go fast. And of course, when they go fast, they rattle a lot more, so they emit a lot more sound. So it's easier to pick up the sounds. You also have not much background noise because actually in the tunnel there is no machinery there, other machinery. It's just the vehicles here. So it's a little bit easier to distinguish the sound of the vehicle from the sounds, for example, of machinery that is here. But for some kind of failures, you probably don't want to have the straight line where the cars drive. So, for example, so you have this kind of switching points here where the vehicle comes from the left and goes on the right rail, or you have these U-turns where they can turn around. And later, we also position sensors on these locations just to detect different kinds of failures. So, for example, this control rod in the front of the vehicle that guides the vehicle through the curves. You can really hear it only when it takes a turn. So you have to put a microphone into that. And of course, you have to retrain, you have to relearn the sound because it's just sounding different at these locations. So the machine learning, the learning part that the machine is doing, have to be done you in this location. So it's a little bit more effort that you have to take, but I think it's worse because you can detect this different kind of failures just by switching the position there. Also, what we also learned is, as I said in the beginning, how to scale up the system, how to make this really big. So it's relatively easy to do this in one position. So as we did before on this project with the pumps, to just have one pump there monitor this. But when you now do it for a couple of hundred vehicles and even on different factories worldwide, you have to build a system that's more rugged, that's more scalable. We did this in two things. So on the first picture you saw here, that's the test setup we had here on the rail. Later we had a partner build a really good device for that. So it's a rack case. There's power flowing in, so you can put it anywhere. And it can also be produced by different manufacturers, so in a couple of hundreds or even thousands. So you can really roll this out globally. Also, the cloud architecture, so that's the software part. We had to adapt this just to do this on a global scale, on a bigger scale. So a lot of effort went also into this architecture, into the software, into the code that we've wrote here, that you can really apply it globally to different fabs. And there were also some fun stories along the way. So one of the fun stories is here that was the software team, which went into the fab of GlobalFoundries to install the sensors. And when they did this, that was my team from T-Systems before. So when my colleagues went into GlobalFoundries, I think it was on a weekend. So they went into the clean room. So they put on this clean room suits. You see here the white ones that they can enter the clean room. And then they try to put on the sensor on the rail, and they just selected a spot where there was no Wi-Fi network. So the only spot in the whole GlobalFoundries factory where there was no Wi-Fi network, they put in the thing. And then I got a call, I think on the weekend, and they asked me, okay, do you have some router? Do you have some Wi-Fi router? We need to put an additional one there. And I just happened to have my old one from home. I just switched this out and I said, yes, I have one. You can have this. So we put it into the clean room of GlobalFoundries. You can see it here in the picture. So that's actually my personal router here at GlobalFoundries. So it stayed there for a couple of weeks. So later, when I switched to Infineon, I was telling my colleagues here at Infineon, so the personal router of an Infineon employee is still working at GlobalFoundries and making sure that critical data from the microphones goes into the cloud. They switched it out, of course, in the meantime, but it was a very fun story, and it tells a little bit how we work together. So even different companies, we might be competitors in one area, we're working together in other areas, but it's something I think this is especially here in the region of Dresden and Silicon Saxony. So a lot of cooperation going on. So a lot of things we do together to solve common problems we have here in the industry. Okay, so let's just end with a small outlook. So what are we doing currently? So there are some follow-up projects there. So we want to also include additional sensor data. So there are now people here working at GlobalFoundries to have a camera also in there. So not just listening to these kinds of robots, but also to have a visual inspection. So what they're doing is they mount a camera that's looking on top of the vehicle, and then you can also see some different failures, so just by not listening, but by looking at the device. So now it's a visual inspection. So for example, the casings of all the vehicles are white. That's good because you can see, for example, example, some debris from the brakes. It's accumulating on top of the vehicle, so it's some black stuff accumulating there, and you can see this with a camera. So that's the kind of things they try to do now, to also look for those different kind of failures by integrating a camera there. They also want to measure the vibration of the vehicles, how they are swinging, for example, when they go through a curve. So they use some accelerometers so that can detect this vibration. Again, a different kind of sensor they want to do here. And for us at Infineon, we now deploy the same system here in our fabs because we use the same robots than GlobalFoundries. So we now are here in the process of deploying the same system here to monitoring our robots. And for us, it's very important because you might have read in the press that Infineon is building a new fab. So here in this photo, all this green area that is here in the parking lot, you see here on the right hand corner, that's actually a building site at the moment. So if I'm looking out here on the window, it's a big hole here. We're building a new fab here, so a big new fab that's producing the semiconductors, especially the power semiconductors. And we will have a lot more of these kind of vehicles here in the fab going on. So it's very important for us to monitor them very efficiently, and we want to use this new kind of technology, this type of predictive maintenance solutions to make our inspections of these vehicles here better. Yeah, so that's the things I wanted to show you. So a touch sensor from Infineon doing the work of a highly experienced maintenance specialist. That's something we do here in the semiconductor industry, but as I said, you can also apply this to other industries, a lot of other industries going into that. So doing predictive maintenance, really seeing if something breaks, and it's very important if you can detect it before something breaks, if you can make sure that the machine is taken care of before really a big outage or something like that occurs. So I hope this was interesting for you. So I hope for some questions you have there. And I'm happy to share my knowledge about the project and about that with you here.
Thank you for the really great lecture, Christoph. It's really amazing to see the factory that you are improving and making better using technology. My first question to you would be: should Thomas be worried about his job if you make a really great system and detect when something is not working properly?
No, Thomas is not worried about his job because it just makes his life easier. So he doesn't have to go around there, have to listen to the machinery, have to do it. He can just look on the screen. He sees the vehicle which has the most, it's most likely to have some breakage, and he can take care of that vehicle first. So it's not endangering his job. It's just making his job easier. And I mean, it has been almost the way. So, for example, if cars came into the world. So maybe the ones who were transporting people before were, they feared of their job, and it was not a way. It was always with new technology, jobs becoming obsolete, but new opportunities. A lot of new opportunities are coming up, and you just may change the way how you work, but there's not much people getting unemployed or something like that. So that's not a fear.
Okay, so in your opinion, what would be the essential skills for a successful tech career? I mean, now we have students watching this lecture in elementary school and high school. What should they focus on mastering when coming to the university and even after that?
Yeah, so I think the main thing is you should be curious. You should be curious about to understand things, to understand the science behind the world, how the world is going on. So be curious. I think that's the most important part. Of course, science helps a lot. It's a lot of science we employ here. So be good in mathematics and physics, mechanics. So all this STEM lectures, they are very good. But I think it's not the only one. So just be curious. new technology. I think that's the main part. And of course, these lectures help, I think. Yeah.
Yeah. And we have one question from schools. They're asking what happens if sensors or cameras are not working as intended. Maybe they're producing some noise or not working at all.
Yes, so that's what I said when you scale the things up. So it's easy to do this kind of work just on one vehicle with one sensor. You can see it. But imagine a situation where you have worldwide a lot of fabs, and you have in every fab you have this kind of system, and you're looking, for example, or you're listening to 1,000 or even 10,000 of these sensors at once. So yeah, yes, they can break. It happens, but you can see it. Also, the artificial intelligence that is in there, so the programming code can also monitor the sensors itself. So it should be able to see if a sensor, for example, breaks down, if it's not producing an output, for example, or if it's producing a different output than before, then you can see it, and then you can just change it. What you need is really a good scalable system. So as you saw on the first picture, just this lab setup we had that would be difficult, for example, to change. But the box we had from the other partner in the end, that's relatively easy. You just change the box, put a new one in, connect it to the system, and then it's going on. Yeah.
And how does the artificial intelligence know whether the machine is working properly or not? Or how do you teach artificial intelligence to detect whether machine is working properly?
So what we do is actually teaching the machinery, so the neural network, to distinguish between these two kinds of sounds. So usually you have this normal, so the vehicle is just fine, and you have a normal signal there. And of course, there are lots of vehicles going by. So every one of these few hundred vehicles goes by the sensor box a couple of times per day. So you have a lot of data of just normal vehicles. So you train the machinery on those normal signals, and then of course you have from time to time you have a failure there. So you have a vehicle that sounds different, and then the technician can say, okay, that was a ball bearing that was damaged, or it was a brake, something like that. And then you tell this the system, and it learns by just listening to the vehicles. It learns every day more and more to distinguish between these kinds of sounds. So you need a lot of data for that to do this training. That's why we use a cloud system, so big computing centers to store the data and to do this. But it's just the same way like you would learn something. You look at a normal thing, you look at a faulty thing, and then you can distinguish between the two of them.
Okay, we have a few more questions. Are you using your own sensors to detect sounds, or are you using commercial ones?
These are commercial ones, but they're actually from Infineon. So as I said, it's a small sensor from Infineon. You can usually find this here in your phone. So it's the same type of sensor. So companies, for example, that are producing this type of phones, they buy them from Infineon, and we use them here just internally. Of course, because they are the best sensors you can find on the market for this kind of application.
And what kind of power supply do sensors use?
So they need a very small power. So usually you do this. You can connect the power supply to the box, but usually you do this with an Ethernet cable. So you put Ethernet on the box, and also the Ethernet is in the same time just providing the small power the sensor needs. So you don't need a lot of current there to do this. You might run it on batteries, but again, as I said, if you have 1,000 or so, you don't want to change the battery. So it's usually just by power over Ethernet, that they are powered.
And another question is, how is system protected from I don't know, from hackers, viruses, or something, or someone doing something bad?
That's a good question, and it's very important. So you saw this complex architecture there, also which we built on the cloud, and a lot of the effort actually is going into make sure that nobody who has not the right cannot access the system and can do damage there. So what you do is you secure the signals. You may encrypt them, and we transport them to the cloud encrypted. So even if somebody hears something from the signal, he cannot do anything with that. So a lot of the effort going into this into the cloud software is actually making sure that it's secure and reliable.
Mm-hmm. And the data you are collecting, is it saved to the cloud, or you just delete it after you do the analysis?
Mhm. Actually, both is correct. So as I said, there's the edge AI part, which is close to the sensor. So that does the processing of the data. So more or less, the sensor itself can decide was this AI if the signal is okay or not that it's currently listening to. So you don't need the cloud to do this inferring part. But of course, we transport also samples from the data to the cloud, collect them there so that we can refine and retrain the model. So, for example, you have heard something new, some kind of failure you didn't have before. It's get transported to the cloud so that it can be merged into the model, and then the model is going back to the edge AI to the sensors, and then the sensors can again, with this new knowledge, can detect different things.
Yeah. And the thing that I'm really wondering, and probably many students that are watching the lecture, can you describe the experience in Silicon Valley and compare working in a Silicon Valley in a epicenter of tech development and working in Europe? What are the biggest differences?
Yeah. So actually, I worked a lot in the Silicon Valley also, and so Silicon Valley, the region between San Francisco, San Jose, in California in the United States. And I think the Silicon Valley there, it's still the epicenter of innovation, especially in software. So still a lot of things are going on. Which struck me is when I'm here in Dresden and we're talking about the Internet of Things, which is not only about software, but which is also about hardware and connectivity. So it struck me that a lot of development is going on here regionally. So to find the top providers for the Internet of Things, you don't have to go to the Silicon Valley and just go out the door here, go a couple of hundred meters and find companies who are building here the Internet of Things. So that's because a lot of this hardware manufacturers, so like Infineon, Global Foundries, the other ones, are here in the Silicon Saxony area, and also software companies. So as I said, T-Systems, SAP, they are here. A lot of the other ones, even a lot of small startups being here. So you don't have to go that far to find good companies, especially in this Internet of Things. So I would say still, yes, the Silicon Valley is very relevant. United States producing a lot of innovations coming from there, but still in having applications for this technology, really doing stuff in fabs. There's a good place to go to Dresden and the Silicon Saxony area.
And in terms of Europe, where do you think that we can be the best at? I mean, in Silicon Valley, you have many the biggest platforms that emerged. Where the Europe can be the best in the world?
Yeah, I mean, we are in some kinds we are the best in the world. So as I told you in the beginning, Infineon is number one. So in some kinds of hardware, so power semiconductors, for example, there's number one. Is Infineon? It's a European company, a German company, and I see at the moment a lot of companies going back to Europe and building fabs here. So it's not only Infineon, also other companies like TSMC, for example. They are thinking of going back to Europe, building fabs here. So that's something I think we will see a lot more development here in Europe. Because I think also Europe is on the forefront of decarbonization and digitalization. So a lot of companies, a lot of countries here going into using renewable energy. So it makes a lot of sense to also build the chips and also build the technology here in Europe. So we won't be alone. Of course, there's a lot still going on in Asia, a lot in the US, but I think Europe's getting stronger in that area at the moment.
Okay, well, I think we came to the end. So maybe some final note to the students. What can you tell them to remember?
Yeah, so thank you very much for joining. I hope I could spark some interest in you into these kind of new technologies. And you see, it's not only about the technology, it's about the applications. So really to make life easier, to make life greener, to make the future more enjoyable for all of us. So I think it's a good way to do your studies. And yes, look on mathematics, look on physics, look on chemics, all the STEM lectures. And yes, if you join the industry, I would be happy to maybe some of you seeing here interest in, at Infineon working on yes, digitalization and decarbonization.
Yeah, so I read on your LinkedIn then that you're basically creating technology to create value for the customers. So and we like to say the students are not going to schools to get great grades, but they are going to school
Yes.
to learn technologies to solve problems in the world. So
yeah, you have it in your own hands to build a better future.
yeah. So you heard everything. You have big responsibility to solve all of the problems in the world, but start with small steps. Find some friends that are passionate about something. Start working on a project. Maybe start a company, and who knows? Maybe Infineon will also acquire you someday. So or you'll be working with Infineon. Christoph, thank you very much for the great lecture, for your time. I know how super busy you are. And yeah, that's it. Thank you everyone from joining in, and we'll see you around. Bye.